Hello and welcome to RFree 103, where we're going to talk about antenna height and coverage. My name is Paul. I work at the Prometheus radio project. This screen share is going to get pretty technical and I'm going to have to gloss over some details, so I just want to give you some warning in advance. But generally we're going to talk about how your antenna height affects your coverage, how you know what your coverage might be, and how you might know if choosing a height other than the one recommended in RFree will still be good enough for you. We're going to use the same old example we've been using. This is a antenna mounted on top of the public library in Farmington, New Mexico. On the left you can see the anticipated coverage area, and we're going to talk a little bit more about that. It's in blue. You can see a much larger version of that on the coverage map page. And I'm going to turn this into a terrain map to show you something in particular. This coverage is produced using an FCC formula which takes into account the height above average terrain in any particular direction. And generally, if you're higher above average terrain, the FCC formula predicts the signal will go further. For example, here's your antenna. And here you can see is a river valley, and that river is probably flowing, I don't actually know which way it's flowing, but this land is lower than this land in general and off into this direction. And so the formula predicts that the signal will go further in this direction. This makes sense if you think about it. The closer you are to being able to actually see what we call line of sight, the further the signal is likely to go. It works the other way too. If your height above average terrain is lower, the signal tends to not go so far. So here you can see that in the lowest part of this river valley it goes further, but as you come around to the sides of the river valley and the land gets higher and higher, the height above average terrain of this gets to be less. Well, what is the height above average terrain? Let's look a little bit more at that. Here's a diagram in the Prometheus transmission toolkit. And this is how we describe height above average terrain, since it's a pretty confusing concept. On the left is a transmission antenna. The dotted line is the height of the radiation center of this antenna. And you can see that this dotted line is some height above the ground. That's the height of the antenna above the ground. This dashed line is the height of the average terrain in that area. And you can see some of the terrain is higher and some of the terrain is lower, and when you average it out, the average terrain is here. What this means that in this case, the physical antenna is taller than the height above average terrain. In the case that we're talking about in Farmington, New Mexico, and in many cities, it's the reverse. In those situations, the height of the city is much lower than the surrounding terrain. Much lower. It's like being in a bowl. And so what happens there is that an antenna to be at the height of average terrain, let alone above the height of the average terrain, to be even at the level of the average terrain, the antenna needs to be quite high. So in those cases, you see what we saw in Farmington, that in the example we're looking at, based on the terrain there, for an antenna to be 30 meters above average terrain, consulting the terrain databases meant that it needs to be 103 meters above the ground at that location. Now, just a brief digression, RFree figures this out in an FCC approved way that uses 8 directions evenly spaced: north, south, east, west, northeast, and so forth. The 8 evenly spaced directions. There's a height above average terrain in each one of those directions, and it's a different height. RFree averages them, and that is an accepted method and approved method at the FCC for figuring the height above average terrain of the site itself. It is, again, an average. At any rate, this height above average terrain takes into account terrain that's quite far away. So let me see if I can find a good example on Farmington. This blue area is the predicted area of the best quality of your signal. It's called the 60 dBu service contour. People with even crappy radios in this area should be able to receive a pretty good signal. That's the theory. Now let's back out a little bit. You'll notice that these mountains here look pretty prominent. You'll also notice that the signal here is pretty drawn in. It's as close as it gets. It's the shortest transmission distance that there is. However, the signal, it says that the signal stops here, but the actual land mass that's being used in the FCC calculation is actually out here. Now this one looks pretty sensible because it looks like it stops where the rise begins, but that's usually not the case. So let's look over here. It's showing that the signal ought to go the furthest here, but if you think about it and you look at a line from here to the transmitter, there's some pretty high land here. And also, if you look off into the distance, this low river bottom land goes quite a bit further. So one of the things to keep in mind is that this formula can be imprecise. And so how is a person supposed to know what antenna heights will actually work? Well, this prediction isn't terrible. I'll start with that. It's actually a really decent prediction for higher powered radio stations looking at further distances than an LPFM would usually look. And it's not quite as good for LPFMs, but it's better than nothing, and it's better than just a circle. Speaking of just a circle, the FCC graphs and software that we use for this prediction have a limitation of 30 meters above height above average terrain. What that means is what's happening is in this direction, to choose one, sort of directly east, the height above average terrain, according to the terrain database, it's actually the FCC's terrain database, the height above average terrain is almost definitely less than 30 meters. But the software is limited to 30 meters. That means that if it comes up less than 30 meters, the FCC software sets it at 30 meters anyway, which means that even if you're in a deep hole, it's still going to show that the signal will go at least that far. That's obviously not realistic, and it's a limitation we need to deal with. I'll just give you a heads up that whenever you see these smooth sections that look like perfect parts of a circle centered on your antenna location, it probably is because the height above average terrain in those directions is less than 30 meters. So you might imagine that this signal this transmission distance that's getting nearer and nearer and nearer might actually be coming in and go around like that. We don't really know what it is because the formula doesn't take it into account. Doesn't take into account heights above average terrain less than 30 meters. It just sets them to 30 meters. So that's a big caution to think about. Now, let's talk about reducing the antenna height for this station because it's at 130 or 103 meters. If you recall RFree 101, I believe we changed it to 18 meters, and that's what we're going to do here. We put the 18 in, hit OK, and you'll see down here in the table, this is our current antenna height. It's 18 meters above the ground. That gives it an average height above average terrain of negative 55 meters. That's a good indication that we're going to get a lot of the coverage area looking like a circle, and we can run 100 watts at that power. So we'll save this and see what happens. Keep in mind that shape for a second. We're going to get a new one as soon as RFree is done with the calculation. And there it is. You see it's virtually a circle. Let's look at a big version of it. And this will happen in many cases in cities that have high terrain around them, and that's many cities in the U.S. Because they're often built on deltas and in valleys near rivers. So the only direction where the height above average terrain is actually greater than 30 meters is in this direction over here, which means that if the FCC formula accounted for heights above average terrain less than 30, this circular area would probably be closer in. I don't know if that makes sense, but because the height above average terrain is capped at 30 and it can't go below that, they can't pull this signal in even though their formula would predict that if it could. So, can you trust this circle? Well, it's going to depend a lot on the terrain and the place where you're at. And the best thing to do is to know your own location. Can you see the areas where your listeners are from 30 feet on top of the library? There's a couple of ways to figure that out. You can go climb on the library. You could put a camera on a pole and look around. You could fly a balloon up there or a light or something and go around the town and look and see if you can see it. That's not a perfect test, but it's a pretty good test to at least get you started about whether you have line of sight. And people who know the terrain well may have a pretty good feel for this already. It's good to get somebody like that involved. The other thing you can do is look at terrain maps or topographic maps. This Google one is relatively, I would say, relatively encouraging that the main area of Farmington is in this sort of smooth, fairly flat area. Most of the population we want to cover with this theoretical station lives there, though some live up here too. But most of the people we want to cover in this theoretical station are in the main part of the city. So this is looking pretty encouraging. But how would you really know? Well, there are other ways to determine how far a radio signal will go. It's called coverage prediction or propagation prediction. It goes by several names, and one of the most mature ones that's used fairly frequently is called Longley-Rice. And let's see, I think I have a link to it. There is a free Longley-Rice coverage predictor online at this URL, lrcov.crc.ca. That's a Canadian website. That's longleyricecoverage.crc, which is Canadian research something I think, .ca. Now, there are a lot of assumptions that go into using something like this that are highly technical, and I'm not going to get into them. But we're going to go use this and try our two different antenna heights and see what the Longley-Rice predictor says. So the first thing we need to do is go over to lrcov.cc.ca. Be really aware of this warning message here. Please log in. If you don't log in, it's not going to give you any results, and it sometimes is very mysterious about it. You wonder why you're not getting any results, and that's why. It can be very frustrating. And you also need to get an account here before you can use it. It's, I wish you didn't, but you do. It's free, it's easy, and you ought to read their terms of use and so forth, just to be sure. So I'm going to log in. This is a pretty detailed form, and I'm going to go through it and talk about it very briefly, not a whole lot. So, latitude and longitude of the station are the first thing. Now, for those of you who are more technical, I'm going to show you there's a latitude and longitude in both NAD 27, that's one kind of coordinates, and in NAD 83, that's another kind of coordinates. The most modern software and so forth uses NAD 83, that's what we're going to use. So, the latitude 3644, 58.89, this is really not a lot of fun to transfer these numbers by hand, and I know it rounds, so I'm going to say 58.9. 58.9, and then for longitude 108.10 52.6. 108.10 52.6. Did I get that top one right? Net 83, 58.89, 58.9, yes. So that's our coordinates. The height above ground. Well, let's start with our real high antenna, 103 meters. Remember, that's what RFree predicted was the height that you needed to be above the ground to get 30 meters above average terrain. Frequency. Well, 100 megahertz is in the middle of the FM band, so we can just leave it 100 megahertz. The frequency doesn't change the distance all that much. The power is 100 watts, not 1,000. We're not going to do anything fancy with antennas. There are some things in here that refer to the kind of terrain you're at. Are you in a desert and so forth? Farmington is in the desert, so some of these should be changed. I'm not going to change them for the purposes of this. I'm going to change the coverage display here so that it looks a little bit more like RFree. So I'm going to make this one light red, I'm going to make this one light blue, and I'm going to make this one light blue. You'll see why in a minute. Now we need to set the receive area. So this is the area around which the coverage prediction is going to be giving us information. It defaults to Canada. We can set it either with numerical in the form, or we can use the map. I'm going to use the map, which takes a little doing because we need to run it over to New Mexico. Near Four Corners, you can see Farmington showing up there. So here we are in Farmington, and let's set our receive area. Oh, let's set it pretty big. And now we're going to make our coverage map and zoom in. And let's make this a terrain map too, so that we can compare it with this map. Okay. Now this is, remember, at 103 meters of antenna height, so it's a lot higher in antenna than the RFree than this is. This is at 18 meters, so much lower. But let's look at the area covered. So, you know, the center of town is here, and it looks like it goes out pretty far out of town. Let's see what this one shows. It's not the same, but it's close enough. If you look there. Now remember, this is 103 meters. So the red on this is a area where a good car radio or a radio with an external antenna could probably receive a decent signal. And the blue areas are just like the blue areas in RFree. They're areas where people ought to get good reception on most radios. Now, this is pretty encouraging, but let's take the antenna height down to the 18 meters, which is all we can really do at that location. In our fictional example, we can really only go to 18 meters. And now let's make a coverage map. You'll notice it's considerably reduced. The blue area, which is the best listening area, is considerably reduced, which was consistent with what I said. When the height above average terrain is less than 30, the FCC prediction does not draw the predicted distance in any. It kind of gets stuck there. And you can see here that while this is still a pretty good signal for covering a fair amount of Farmington, it does miss some important areas here. And I believe it's starting to miss some areas up in here. But still, it's not terrible, and what this goes to show is that dropping the antenna might not be as bad as you think. So RFree said, hey, put it at 103 meters. We looked at that in the coverage predictor. It was very good at 103 meters. If you could possibly put it at that height, it would be a very, very strong signal. But that's unrealistic. A lot of people using RFree are seeing unrealistic minimum antenna heights, and they're going to have to go below them. In this case, we went to 18 meters, and we still got a pretty effective signal. Now, we could shop around for different antenna locations and do better. And I'm actually going to do that because I've looked at this situation before in Farmington, and I'm going to point something out here. What you want is a place that has line of sight to all of the listeners that you have. And one of the places, in the way I'm thinking of it, is we'd like people coming into town and leaving town to be able to hear this, preferably on 64 as well. And we'd like everybody in the town to be able to hear it. It turns out that there's a bluff down here. Now, I've not been to Farmington in a long time. I have no idea what's actually going on this bluff, but we can actually go and look. There's a little road that leads out there. Let's zoom in a little bit more. You can see that this is a cliff down to the river. And let's switch to the satellite view and go in even closer. And there's something out there. I don't know what it is. But it looks like some sort of a metal roof. Well, a metal roof would actually be a pretty decent place to consider putting an antenna. So, if I was to put an antenna out here, and I'm going to set the position out to here, what would the coverage look like? Now remember, we're still at 18 meters above the ground. And I think I blew it. I didn't actually set it where I thought I had. Try this again. So there it is. Set the position right there. And this should be starting to look pretty good. Let's go for our terrain database. So on this bluff, we get way out of town on the highway there, way out of town on the highway there, practically to Aztec. And remember, this red area can be received on a good radio with an external antenna like a car radio. So out here it might turn red on the way to Aztec, but it'd still be a usable signal for cars. And here in the middle of Farmington, the whole place is flooded with a great signal. So this is a really good location. Now, I'm not sure there's any electricity there. You might need to put solar power there. It might be government land. You might not have any permission to put an antenna. And it might not be a place you could put an antenna. Well, how would you know? Back to RFree. Let's change the location to the same location in RFree. Now, we could copy the coordinates into here, and that would be the most precise thing to do, and I would recommend that you do that. But I find that I'm pretty impatient, so I'm going to go ahead and just do it manually. It's this bluff right here, if I'm remembering correctly. That's interesting. I'm getting different image here. Well, that's still a nice metal tank. Let's use that. So let's get it close. And even closer. And put it right on that tank. And check. Now, to be more thorough, you'd want to actually copy the coordinates across from one to the other, and like I said, that's really not something I find a lot of fun. So we find out that the same sort of frequencies are available as before, so we haven't, by moving to this place, caused ourselves any particular problems. We haven't chosen a frequency for this example lately, and that's not part of this example. Our example here was more about, can you lower your antenna below the minimum specified by RFree and still have good coverage? And then we discovered that if you use this coverage predictor, that you can sometimes find other locations that it predicts will produce even better coverage. Oh, the other thing I should mention is that when we moved the antenna, RFree set the antenna height to achieve 30 meters above average terrain, set it to 26 meters. We can probably build a 26 meter antenna at that site. So let's set our antenna to 26 meters and let it recalculate our coverage, and we should get slightly better coverage, because whenever you put the antenna higher, you get better coverage. And sure enough, that coverage is a little bit better. So we've learned that antenna height is an important factor in figuring out how far our signal will go. We learned that the FCC formula for predicting how far the signal will go, which is the formula used by RFree, has some challenges in certain types of terrain. We learned that there is a free predictor, this Longley Rice predictor. You should go ahead and read all the disclaimers about it. And I didn't even fill in the desert parameters like I was supposed to, but it gives you a rough idea, a better idea than RFree can in these situations, whether a lower antenna might still serve your listeners. Thanks for listening to RFree 103. My name is Paul. I work at the Prometheus Radio Project, and I look forward to seeing you again for another RFree screencast.